All right, so oftentimes when I describe what LIDAR is to clients, they usually just kind of nod their head and accept it for what it is. So I wanted to show you this little video of how LIDAR can be used to help architects start accurately and to document existing buildings. Here we have a church that was built in the 1880s and it has been documented, but there are no existing architectural drawings. So we spent about 2 days documenting this building with our LIDAR technology, and you can see on our little model here the little tripods that have the LIDAR scanner on it. So we basically will take this little scanner and walk it around the site and hit it with laser beams, and those laser beams measure the building to within a couple millimeter accuracy. And you can see from the ground we were able to capture exactly the height of this cross element here, and also the height of any roof. And like I said, it's within a couple millimeter accuracy, so we can actually determine if this thing has changed over time as well. So if you have some structural damage, we can compare point cloud data to older or newer point cloud data and measure the deflection between the two. You can see it also captures a lot of the landscape throughout the site. We actually get the diameters of trees, the heights of tree, and actually it'll even capture the guy who is actually scanning the data there. That happens to be me looking on my phone while it was scanning. You'll also notice that the data contains elevation information, so we are able to look at how the terrain slopes and see if there are any issues with drainage. So a lot of times we'll have sites that are draining into the building and causing a lot of structural problems. We can actually use this data to give us a good estimate or a good understanding of where the sloping occurs on the building. And you can see it's pretty extensive. We went through, like I said, 2.5 days. We captured not only the church, but the parking lot, the entire facilities, the rectory, and there's also a school on here as well. So you can see when this thing loads, that will start to bring in the data for the entire school. So I'll let that kind of load as we're walking around the site here. So this was one man, 2.5 days, capturing this entire complex within millimeter accuracy. So sometimes you're like, well, that's cool data, but what do you do with it? Oftentimes we'll find that there is vertical information that we never would have captured, because normally we would be running around the site with a tape measure, measuring all the ins and outs of these, and we will neglect or forget to capture vertical information. So say we wanted to find out whether or not our building will hit this wire. We have now captured that information in the building so that we know that. And there's oftentimes things that you'll be out on site measuring that you never think you're going to need to know. This technology allows us to capture that building. The other thing that's a benefit of this is, say perhaps this building were to catch fire or burn down, or we needed to reconstruct it. Oftentimes these buildings built around the 1900s were not documented very well. They were usually relying quite heavily upon the ability of the masons to build the building within the scope, and they usually have just general overall drawings of the building. This way we know exactly what this building looks like and we could recreate it. So it is a great way to, if nothing else, capture the building. I mean, even for insurance purposes. But it also offers the architect an incredible starting ground, and the engineers and mechanical designers an incredible starting ground for the commonality between the measurements, so we know that we're all working off the exact same building. Another fascinating part about this technology is it actually captures the color information and the light texturing information on the building. So you can see here we're capturing what the actual stones look like, and we're even capturing the measurement of this stained glass window. Now I didn't focus heavily on this window, so it's missing a little bit of data, but we could certainly have measured that exactly how we needed to if we knew that we were going to be replacing or doing something with that stained glass window. You can see also that it includes the interior as well. So in, like I said, the 2.5 days, we got the interior of the church, and we also got the interior of the school, all captured within millimeter accuracy. So we know exactly if a column or a wall is deviating or if it's not straight. We can measure that in this model, things that we could never actually capture while we're out on site. Now, one thing that people often comment or ask about is, can you tell me what's in the wall? Can it find pipes and electrical wires and structural pieces? The answer to that is no, and that is where the existing drawings or the construction drawings that exist for the building are very useful for telling us what is in the wall. That's the only downside of the LIDAR, is that it is line of sight, so we have to make sure that the LIDAR can actually see it in order for it to actually measure something that is there. And you can see inside here we've got all the documentation and vertical information of this church. We can see how high steps are within millimeter accuracy, so if we know we have different varying steps, we're not out here with a tape measure measuring that. Often find that even in steps, something small that we never even kind of think of while we're out there is what the treading or the nosing on the church, the steps looks like. So this is the nosing on the steps. We can actually cut through the building and look at it. And you can see through a little bit here, we've also captured the basement on this building. So if I kind of orbit down, you can see inside of here, we've got the basement of the building. The other thing that's incredibly useful for this, for documenting a building, is it gives us the vertical information. So we know exactly how thick the floor is from the top to the basement and to the ceiling. So that's often a very tricky thing. You'd think it's pretty easy to measure where floors are connecting. But when you're actually measuring with like a tape measure, it does become quite tricky to figure out exactly where floor to floor heights are. So you can see inside of here, we have the stairwell that we captured. And we use that stairwell information to connect our top floor and our lower floor to get the exact elevation of what this floor is, this landing, and then the basement elevation as well. You can see here we can look down the basement. Now, in order to speed it up, we did switch to a black and white scan here, but we didn't find the color information was as important, but we did find that the measuring information was important, so we just turned off the coloring for that. And you can see as I come out here, we can look at the building from any direction. We can look at the roof and see if there's elements on the roof. So I did do a couple scans up on the roof so that it can tie together any of the roof elements along this property here. So it's a great way of documenting historically anything that exists on the building. So it can be quite useful for historic preservation projects where you need to demonstrate that you're not changing much of the exterior if it has to go through a historical preservation review process. Okay, and you can see inside of here, we actually got a lot of the playground, if that loads up as well. We'll kind of spin around here. We got playground information. We actually captured all of the fencing along here, any cars. What's also great is it can capture any elements on like concrete or surface properties. If there's elements that are kind of heaving or lifting up, we can capture all that element in this quite effectively. So I hope this gives you a little bit of an overview of what exactly LIDAR technology allows us to do, and the incredible accuracy that it allows us to give us to start from, and to start your project on the right foot. So that is often the key. The first thing an architect's going to want to know when he comes onto the site is exactly what you have and what the measurements are, so that they can accurately draw their drawings, so that when the architect is starting with proper drawings, you will hopefully minimize the amount of change orders and incorrect measurements that were taken on the field using older technologies such as tape measures. All right, so hopefully that gives you a good overview of what the idea of LIDAR technology is and how it can improve your next building project or historic preservation project. All right, we'll see you later. Thanks.